We are going to continue on in our lessons about function transformations. This is part 2, and our objective here is to understand function transformations. So I'm going to go over the different transformations that you'll need to know and show you an example. Okay, and then in the next lesson, part 3, is where we'll actually do a lot of example problems related to transformations. Okay? So the first type of transformation that we are going to talk about are horizontal and vertical translations. So horizontal translations are moving the function from left to right. Vertical translations are moving the function up and down. Okay, so what this looks like is if we have y is equal to f of x minus d, it means that the graph, or the parent function or the mother function, has shifted to the right d units. Okay, notice the minus d goes to the right. If we have y equals f of x plus d, it's the graph of the parent function, y equals f of x, shifted to the left d units. Okay, so the plus sign here goes with left. For vertical translations, this is up and down. So if we have y equals f of x plus b, this is the graph of y equals f of x shifted up. Okay, so this plus b is going to move our graph up. Y equals f of x minus b is the graph of f of x shifted down b units. Okay, so let's take a look at a couple of examples. Example 1, horizontal and vertical translation. So let's just focus on f of x is equal to x minus 2 squared. So the parent function here is x squared. We have x minus d, okay, where in this case d is 2, and we're shifting to the right 2 units. So what this looks like, so the blue line that you see is the original. This is x squared. Okay, and the red, is our f of x. Okay, so I've put them both here just to give us a visual, but notice this is a shift to the right 2, so every point goes to the right 2 units. Okay, so 1, 2. So every point on our blue goes to the right 2 units, and we get our red. Okay. For f of x equals x squared plus 3, again, we are working with the mother function of x squared. This plus 3 means everything's going to go up 3 units. Okay. So we go up 1, 2, 3, up 1, 2, 3, up 1, 2, 3, up 1, 2, 3. Okay, and that's how we're getting f of x equals x squared plus 3. And again, that's the green that you see. Okay. The next type of transformation are reflections. So a reflection across the x-axis means we have something y equals negative f of x. So for instance, this could look like y equals negative x squared. Okay, I'll show you examples on the other slide. Reflection across the y-axis, y equals f of negative x. So this could be something like square root of negative x rather than just the square root of x. Okay, so what this looks like, I did have square roots here. Okay, so again, the blue is our parent function and the red is the function that's undergone the transformation. So we have this negative out front. This means reflect across x. Okay, so it's like if you were to fold this across the x-axis and imprint the blue line where it lands up across the x-axis, and that's where we get the red from. Okay, and notice here that this was the point 1, 1, and instead of 1, 1, we have 1, negative 1. Okay. For f of x equals a square root of negative x, this is a reflection across the y-axis. So again, if we were to fold this, let's say the blue line wasn't there. If we were to fold it and imprint it, okay, we would get the green line. Okay, and notice here we have a point at 1, 1, and our corresponding point when we reflect it across the y-axis is negative 1, 1. Next, horizontal stretching and shrinking. So it looks like y equals f of c times x, okay, and there are some things to remember here. If the absolute value of c is greater than 1, that means that we have a shrink, or our graph is getting closer, it's trying to hug the y-axis, okay? If the absolute value of c is in between 0 and 1, then it's moving away from the y-axis, okay? So it's stretching out away from the y-axis. And note that if c is less than 0, there's also a reflection across the y-axis, which is what we saw on the previous slide. Okay, so here's what this looks like. So I've taken the parent function of absolute value of x. So for f of x equals absolute value of 2x, this is a horizontal shrink. by a factor of 2. And notice the red, so again, this is, and blue is the original, is the parent function. Okay, this is trying to hug the y-axis. Okay, so that's my shrink. It's getting closer to the y-axis. Okay. For f of x is equal to absolute value of 1/4 x, okay, my blue is our parent function, and green is the new function, or you can call it the baby function as it came from the parent function. There's different illustrations there that you can think about, but notice it's been stretched out. It's moving away from the y-axis there. Okay. Next, vertical stretching and shrinking. So with vertical stretch and shrink, we have y equals a times f of x, so it's being multiplied by something out in front. If the absolute value of a is greater than 1, then we have a stretch. It's going to move away from the x-axis. And if the absolute value of a is greater than 0 but less than 1, then it's going to shrink or flatten to the x-axis. Okay. And then again, or a note that if a is less than 0, there's also a reflection across the x-axis. So here's what that looks like. So taking our parent function as x cubed, or our cubic function, so f of x equals 5x to the third power. This is a vertical stretch. By a factor of 5. Okay, and it's being, so here is my parent function and the red line is my baby function. Okay, so the red has been like stretched or pulled away from the x-axis. Okay. Notice we had a point at 1, 1, okay, and it went to 1, 5. Okay, 1 times 5 is what's giving us that 1, 5. Okay. The next one, f of x is equal to 1/4 x cubed. Our blue is our parent, our green is our baby. This is a shrink, or it's getting closer. It's trying to hug the x-axis in this case. Okay, it's a little hard to see. I can zoom in here as well. So it's moving closer to the x-axis. Okay. So if we put it all together into one big equation as to what we can look at, we have y equals a times f of, we can have c times x minus d plus b. So a is our vertical stretch or shrink. Remember, if a is less than 0, then there's also a reflection across the x-axis. B is our vertical translation, which moves the parent function up or down. C is our horizontal stretch or sink. If c is less than 0, then we have a reflection across the y-axis. And D is our horizontal translation, which will move our parent function left or right. Okay. Thank you for watching. In our third part, we will go over some more examples.